5/8 is negative 2 to the power 4. You typed it in a calculator quickly, and you discovered it was 16, right? But we're not sure if we even typed it in right, so let's actually break this down. What's our base?
2.
Yeah, or negative 2, right? And our exponent is 4. Okay. So essentially, the exponent tells us how many times to multiply the base by itself, right? So what I'm going to be doing is I'm going to be writing negative 2 times negative 2 times negative 2 times negative 2, right? So I've written it out a lot. I've written it 4 times exactly. I'm going to solve these as a pair. What is negative 2 times negative 2? Positive 4, right?
Yeah.
So because it's a negative times a negative. So now I have positive 4 times negative 2 times negative 2. Solve it as a pair again. What's 4 times negative 2? Negative 8. We still have times negative 2. And what is negative 8 times negative 2? 16. So we ended up with a positive number, we were right. And it's because we multiplied negatives an even amount of times, right? So if our exponent is ever positive and we have a negative as our base, we're going to get a positive answer. What if the same answer we had negative 2 to the power of 3?
Negative 8.
Yeah, it would be negative 8, that's right. We're going to have a negative number because we're doing an exponent that's an odd number.
Also, if it's always even, it'll be
As long as the base is a negative, even if the base is positive, anytime we multiply by an even exponent, we're going to get a positive answer. Okay? That changes when we have odd numbers as exponents. Does that make sense? Okay. Now, I'm going to show you something that's a little different now. So in the previous question, you notice the exponent was in brackets. Okay. Next question, let's say, I think it's 5b. Is it? Yeah, 5b. 2 to the power of 4. I have no exponent in brackets here. So I want you to think of this as this power of 4 to the base of 2. And this is almost like negative 1 being multiplied on the outside. Okay? So we just keep the negative on the outside. What is 2 to the power of 4? What's that going to be? 16. And then when we apply the negative, what will we get?
negative 16.
So we have a very different answer from what we had before. Okay? So unless we're in brackets, we're not going to get the same answer. Does that make sense? I'm going to put it on the other page so you have something to compare against. Okay. Now, do you remember what the rule was when we had a negative exponent? You did it a little earlier. What happens if I want to make it a positive exponent?
To bring it down.
Yeah, so I put it above 1, make the reciprocal, right? So I have negative 3 to the power of 4. Okay? So now, this is like the exact same question. Only difference is I'm working on the bottom of the fraction. I keep the top the same. I still have it over 1. I have a even exponent with a negative base, so my answer is going to be what? Positive or negative?
Positive.
We know it's going to be a positive number, okay? And now we just got to do 3 to the power of 4. So you want to type that in?
81.
Oh, gosh. 81. Perfect. So what is our final answer?
That?
Yeah, which is? Read it to me.
Oh, 1 over 81.
Yes, good. So it's not just 81. It's 1 over 81. So it's actually a very small number. It's a fraction. Does that make sense? Okay. Same idea. Negative. Now, this is very similar to 5b. You think you can talk me through what order I do these things in?
You bring that negative 3 or down, and leave that negative up.
Ah. Is the exponent negative?
Oh, sorry.
No, the exponent's not negative. That's okay. So what do you think I would do? Okay. So good. We do negative 3 to the power of 4. That's our base and our exponent. And we know it's going to be what? 81? Pretty good last question. What about that negative sign? What do I do with it on the outside?
Multiply it.
Yeah, that's right. Keep it on the outside. Think of it like we're multiplying it to the 81. We're distributing it. So what is our answer going to be?
Negative 81.
Negative 81. Again, very different from our other answer, depending on what's in our exponents. Does that make sense?
Yeah.
Okay. next question 5e says, our base is a fraction, 3 over 4, instead of power of 2. Okay. What we need to do here is this is essentially saying I multiply this base by itself twice, right? So I'm going to rewrite this out. I'm going to get 3 over 4 times 3 over 4. When you multiply fractions, what do? Do you know?
You multiply the base.
Well, when you multiply fractions, you multiply top numbers by each other.
Oh, sorry, yeah.
And bottom numbers by each other. That's okay. So we get 3 times 3 is over. That's all there is to it. Okay. F. 3 over 2 to the power of negative 2. Okay. Now, what I'm going to do is I'm going to go back to this question here. I'm going to try to make sense of what we've done. So technically, I'm going to do it in red. This will be our side calculation of what I did up there, okay? To get to this. Technically, I had negative 3 over 1, and it was to the power of negative 4. Well, you notice I just all of a sudden created a 1 out of nowhere? Technically, what is negative 3 as a fraction?
Negative 3 over 1.
Yeah. So, to make the exponent positive, all I did was I flipped my fraction. I got 1 over negative 3 to the power of 4. Now, again, if you notice, I put the power of 4 on the bottom, but technically it was applied to the top because I had to do 1 over negative 3 times 1 over negative 3. This is what it really said, okay? We just kind of cheated along. And lucky for us, we knew that when we multiplied negative 3 times negative 3 times negative 3 times negative 3, we got positive 81, right? What about when I multiplied 1 by 1 by 1 by 1? 1. Just got 1. So I didn't put the 4 on the top number, but technically it was there. I knew personally it wasn't going to change anything. I should have pointed that out to you. Okay. So I've turned it into a fraction. That's why working with fractions help us make a lot of sense of things. So I got a fraction right here. It's negative 2. How could I make this base fraction? Sorry, this is not a fraction. This is the exponent. But the fraction is 3 over 2. How can I make this fraction a positive exponent? What would I have to do to it?
Would you bring the 2 down also?
Well, remember what we did over here?
The 3 down?
Remember what we did here? We had negative 3 over 2. What did I do?
Oh.
I flipped them, right?
Yeah.
I put the negative 3 on the bottom and the 1 on top. So what would I do with this stuff here, do you think? To make this a positive.
The 3 and 2.
Yeah, so I get 2 over 3.
You didn't flip the 2?
Yeah, the 2 would come up, right?
No, this 2.
What does that 2 become?
Positive.
Okay. So does that make sense so far?
Oh,
So
I thought you'd bring it down.
It's still technically applied to everything, just like over here. So technically, remember, when I flipped this fraction and it made the exponent positive, I applied it 4 times to everything. The only thing is when I applied it to the number 1, it didn't change the 1. It changed the bottom because we had negative 3. Okay. So think of always things, this is why it's easier, if we always think of things in fractions, these questions will actually make a lot more sense. So now I have 2 to the power of 3, 2 over 3 to the power of 2. I would write that out like this. 2 over 3 times 2 over 3. What are we going to get when we multiply those? 2 over 3 times 2 over 3. Let's put that next to 4. Over 9. Yeah, that's right. 4 over 9. So our original question, 3 over 2, the power of negative 2 is 4 over 9. Does that make sense?
Yes.
Okay, so question 6a says 3 to the power of 0 plus 2 to the negative 3. Okay? So you're right. Very first one to start off. 3 to the power of 0 is what number? When we equate it. 1. That's right. So we have 1 plus 2 to the power of negative 3. Now, they want this as a positive exponent. So actually what I'm going to do is I'm going to change this whole number into a fraction. So what would our base, 2, what would that be as a fraction? Just the number 2 as a fraction. How can I represent that?
1 over 2.
2 over... calculates 2 over 1 to start.
Oh,
Right?
sorry.
You skipped a step. So we have the power to the negative 3. And now they want positive exponents only, right? So in order to make that exponent positive, we have to flip the fraction, find the reciprocal, right? So we end up with 1 over 2, like you said, to the power of 3. Now, there's two ways of doing this. I showed you on the other page, and I'm going to quickly show. This will be our side calculation, okay? We know that 1 over 2 to the power of 3. We know that we can represent it like this, where we multiply all the exponents, all the fractions by each other. And what would I get?
8.
Yeah, 1 over 8. Another way I could have solved this, so let's say or, what I can do is I can do this. 1 over 2 to the power of 3 is equal to 1 to the power of 3 over 2 to the power of 3. And then solve. What's 1 to the power of 3?
1.
And 2 to the power of 3? Exact same answer. Okay? Whichever you feel more comfortable with. We can represent it all the way out, or we can just bring the exponent inside. But when you bring it to the inside, always make sure you apply it to both parts of the fraction. Okay? Don't just apply it to the top or just the bottom, because it's going to change everything. So we know that. That we have 1 plus 1 over 8. Did they say how they wanted it as in fractions? No. So we could leave it as a mixed fraction, which is 1 over 8. Or we could do it as improper. We'd have 9 over 8. Does that make sense?
Wait, you want one whole number?
Express each power with a positive exponent, then simplify. So what we did is we expressed each of the powers. We turn this into positive 1, or 1 to the, we could say to the power of 1, but we don't need to put the 1 there because it doesn't make a difference, right? And we changed this to a positive exponent. So we did the first step. Then they wanted us to simplify. So they actually wanted us to add this together. So our answer would be 1 over 8, or 9 over 8, or we could have even put it as a decimal, 1.125. Any of those, I would assume, would be acceptable. 1.125. Any of these answers would work. Okay? We simplified the question in the end. Did that make sense?
Yeah.
Okay, so this is 6b. They wanted positive powers. So very first thing we're going to do in both of these is we're going to flip both fractions so that the exponents are positive. Okay? So we have 3 over 1 to the power of 1 multiplied by 4 over 3 to the power of 2. According to BEDMAS, we always deal with exponents first, right? Before we deal with the actual multiplication of these two things. So 3 to the power of 3 over 1 to the power of 1 is just 3 over 1. Made no difference, right? Now in our other one though, we'll keep a little multiplication up here. 4 over 3 times 4 over 3 was a little different. We end up with 3 over 1 times 4 over 3. So 4 times 4 is 16. And 3 times 3 is 9. Okay. And then finally, 3 times 16 is going to give us 48 over 9. What did you end up with? Yeah. And then you reduce the fraction. You divide it both by 3. So you would have got 16 over 3. Yeah, that's right. Great. You got it. Nice. So normally if we had 3 to the power of 1, 1's not important. You just have 3. Because it's negative, means we're now going to be dealing with fractions, right? So I want to make that a positive exponent. So to be a positive exponent, I have 1 over 3 to the power of 1 minus 1 over 4 to the power of 1 divided by 3. Okay, so what I've done is I've changed these both into fractions. Now the ones are important. I can get rid of those two exponents. And I'm left with 1/3 subtract 1/4 divided by 3. And according to our fraction rules, I need a what? Common denominator. So this will be 4 over 12 subtract 3 over 12 will give us 1 over 12 divided by 3. Now this is confusing. Looks like I've got a triple stack refraction here. Okay.
You can do that though?
Oh, sure. I'm working. Think of it that I'm just working with a fraction right now. Okay. Think of it that I just have a fraction divided by another number. So I'm going to rewrite this. Okay. This is also, so I'm going to put or. This is also equal to 1 over 12 divided by 3, right? Because that's a division sign. And now let's look at our fraction rules for dividing. When we're dividing fractions, we flip them, right?
Would you only flip the right one?
Yep, only flip the right one. So we got 1 over 12 is equal to
Times 1 over 3.
1 over 3. Our final answer, 1,
36.
36. Does that make sense? So anytime you get something like this, a fraction divided by maybe even another fraction or a number, write it in this form. It's a little easier to read, right? Because we can rewrite it any way we like that.
Wait, what did the ones do? They did nothing, right?
At the very beginning,
No, they helped with nothing, right?
these ones here,
Yeah.
what did they do? They made us what? We had to turn them into,
Oh, and we can, yeah.
so they were important. I can't just drop them off because they're negative. Anytime you have a negative exponent, we have to find the reciprocal of our base. We have to flip our base. Okay? Okay, we need to simplify this question. First thing we do is realize that these are all multiplication. Okay? So I'm just going to multiply my coefficients first. My coefficients are the terms in front. So negative 2, negative 3, and 5.
But when you always have to do a negative first.
You mean flip these variables into...
Yeah.
We can, but if you remember your exponent rules, another way we can do this is when multiplying, we can just add or subtract exponents and then work with flipping them after. So I'm going to do all my flipping of negatives after. Okay, I'm going to work with my multiplication rules, just because actually multiplication is usually a little easier than when we're working with fractions or division. Okay, so when I multiply, I'm going to deal with just the coefficients first. Okay, so negative 2 times negative 3 times 5. Multiplication rule, as long as I'm multiplying, I can do them all in one step. So what's negative 2 times negative 3?
6
times 5?
30.
Yeah. We have 30. We've already simplified our coefficient. Now what I'm going to rewrite is my a's. So let's think of it like this. A, close. A to the power of 4. And remember, times A, this is to the power of 1.
Wait, we have to have the plus of them, right?
Yeah, you're right. So because we're doing multiplication rules, so I wrote them all beside each other. I don't really need to write those a's in. What I can do is just add all the exponents together, right? So I have 4 plus, that's to the power of 1,
Plus
and then plus negative 3. Okay? And then I'm going to do the same thing with my b. My 3b terms. I have b and my exponents. This is technically 1, and because we're multiplying, plus 5 plus negative 7. So let's go to our next step. Now we have 30a. 4 plus 1 minus 3 is 2. Okay. And b, we're going to end up with negative 1. Now, the final answer, they said they wanted it to be all positive exponents. So that negative 1, let's think of our rules here. We have 30a squared. If I got to turn that into a positive exponent, what would that become?
1b.
Not 1b, but 1 over b. Right?
Wait, why wouldn't you do it all over? Under all of it?
Why don't I? I'm about to.
Oh.
I'm going to explain it to you. So, one step at a time, that's all I'm doing. That's okay. So, we change this into our fraction, and we know this exponent doesn't change anything, right? But I still have a multiplication question. I have 30a to the power of 2 times 1 over b. Or in other words, 30a squared as a fraction times 1 over b. So when we multiply fractions across each other, right? So I'm just going to add that in there. It's technically we're multiplying fractions, right? I have 30a squared, right? Because 30a squared times 1 is 30a squared. And b times 1 is?
B1.
B.
1b.
Just 1b, 1b, right? So there's our final answer. So what I did is I worked with all my multiplication to start, made it a little easier than changing things into fractions and flipping them up and down. Then when I had a negative exponent, that's when I changed something to a fraction and multiplied across.
Wait, so if you wanted to leave that one, you would have.
So you decided to flip this all and work it out, right? So actually, we'll do that. We'll do that in blue. So if I were to flip that all, I got all of those numbers, 3, a to the 4, b to the 7th. And remember, this is to the power of 3, right? But technically, this is to the outside. So really what it says is all of these, both of these numbers, to the power of 3. The only thing is, when I put the top number to the power of 3, is it going to change anything? No. It's just going to be 1, right? Then we distribute the 3 inside the brackets. So we get 3 to the power of 3, a 4 times 3. When we do power of a power, we multiply them. And b 7 times 3. Final answer is 1 over 27, a 12, b 21. Other way we could have done this question is we distribute it first. Okay? So let's say we distribute it first. We got 3 to the power of negative 3, a 4 times negative 3, and b 7 times negative 3. Okay? So if I were to make this negative, well, I want these answers to be positive numbers, right? So I'm going to think of these individually as their own terms, okay? So I'm going to just separate these quickly, okay? I want to make 3 to the power of negative 3 a positive, so it's going to become 1 over, yeah, or just 1 over 27, you're right. If you could skip the step in your head, that's fine. It's 1 over 27. This one is going to become a 4 times negative 3 is what? Negative 12. And 7 times negative 3? Okay. Same idea though. I want to make both of those positive. Right? So I get 1 over a 12. And 1 over b to the 21. And when I multiply these through, what's 1 by 1 by 1? 1. And when I multiply these, I just get 27, a to the power of 12, b to the 21. Make sense? Okay, we'll finish here.